In this video, as well as the next, we're going to go ahead and kind of put all the concepts from when we looked at quantitative data together, and we might revisit some of the stuff that we looked at with respects to observations, parameters, some of the initial sort of definitions. So we have a scenario to where we have a cohort observational study was conducted, and we wanted to determine if prolonged exposure to violent video games reduced empathy in human beings. So 100 people that have never played video games before were selected to participate in the study. Subjects were administered an initial empathy test that could be scored on a scale of 0 to 30, with 0 being the lowest score of empathy. The subjects were asked then to play a violent video game for 2 hours a day, 4 days a week. Each week, the subjects were administered the empathy test and the results were recorded. So we sort of have like that cohort study as time goes along. And remember, we called that we had a proactive sort of active, or we had that prospective, excuse me, not proactive, but prospective sort of data collection going on. Then we take a cluster sample to derive the observation that constitutes the groups. They were taken in pairs of 3, or I guess in triples, not pairs of 3. And below are the results. Now notice that these are not paired samples. So when we mean paired sample, we mean that this 5 does not match to this 3. All right, they're 2 independent people, most likely. And the only way that they could be the same person is by complete random selection. So we just happen to pick the same person. All right, so these are just random scores out of the 100. So based on the information, we're going to construct a frequency distribution for the week 0 data. And then we're going to include relative and cumulative frequency, and then we're going to use Sturgis Rule, and then we're going to do the same thing for the week 3 data. All right, that should be enough for at least this video. And then in the final video for this section, what we'll do is we'll do all the graphs and we'll make that final analysis. All right, so let's just take this data. I'm just going to cut and paste this for convenience and put it right here. And one of the things you might remember is that we need Sturgis Rule. And remember, Sturgis Rule says C is equal to 1 plus 3.3 log of n. And we have a width was equal to high minus low divided by the number of classes. All right, so these are our formulas that we need. In this case, n, the number of samples, is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so we're going to go ahead and compute the class size, which is 1 plus 3, oh no, class is, not the class size, but 1 plus 3.3 log of 15. And remember, we're going to approximate that to 3 decimal places. All right, so 1 plus 3.3 log of 15. And I end up with 4.881. And now the width. So first we use this formula, right? Now we're using this formula. The highest observation is 28. The lowest observation is 5, right? So we just have 28 as the high, 5 as the low, and we're going to divide that by 4.881. Remember, we need parentheses around the numerator, so in your calculator, make sure you do that. So I'm just going to go ahead and divide this out really quickly. And I wound up with 4.712. And remember, we want to round that off. So we're going to round that off to 5. Right? So that means that the width of the classes is 5. So now we're going to construct the frequency distribution. So we have our classes. Now remember, the lowest observation that we had was 5. So 5 is the lower bound. And then the upper bound that we have is going to be not 10, but remember, we always add 1 less than whatever the width is. So if you don't feel comfortable, count it out on your hand. So it's going to go up to 9. All right, so 5, 6, 7, 8, 9. If you count that on your hand, that's 5 numbers, 5 possible observations. The next class, 10 to 14. Okay. And then we could just keep going from here. So we have 15 to 19, 20 to 24. And then the last class that we're going to have is 25 to 29. And how do we know it's the last class? We go all the way up here. Notice the highest observation is 28. All right, so we're done with at least the classes. And that's usually the most difficult part for students. If students can get down the classes, then they're pretty good with the rest of it. Right? Now I'm going to cut and paste this so that way we just have the information right here. We're going to have our frequency, and we have 4 observations that are between 5 and 9, and then we have, looks like 5 observations, 1, 2, 3, 4, 5, that are between 10 and 14, and then between 15 and 19, 1, 2, 3, 4, 20 and 24, 1, 25 and 29, 1. All right. And then the rest of it should be fairly easy. All right, so let's just get those done really quickly. So we have our relative frequency. And remember the sample size, one way to check it is to make sure that this does indeed add up to 15. We can do a quick glance at that and clearly see that 9, 13, 14, 15 does add up. So this is going to be 4 out of 15, 5 out of 15, 4 out of 15, 1 out of 15, and 1 out of 15. And then finally, for our cumulative frequency, remember we add. So it's going to be 4 out of 15, and then 9 out of 15, and then 13 out of 15, 14 out of 15, and 15 out of 15. Right. So that's going to be our frequency distribution. Now I'm going to clean this up just a little bit because we don't need those lines in there anymore. All right. Now we have to do the exact same thing, except now we're going to do it for the week 3 data. All right. So remember, this was just for the week 0 data, or the initial data. So we're going to delete all this. So we're going to have to do all this over again. Get rid of this because we don't need it. And now we're going to be working with this data. So let's just keep this in mind that we have it here. And we're going to hold on to it. And just like before, first thing we're going to do is we're going to compute C. And before C, we need N. N is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then C is going to be 1 plus 3.3 log of 15, but we already know what that equates to be. Okay, so remember we just computed that to be 4.881. Now the width is going to be different because remember now we have a different high and a low. All right, so the width is going to be equal to 27 minus 3 divided by 4.881. And of course, just like we've done the other 2 times when we computed the width, make sure you put that in parentheses. So we're going to have 24 divided by 4.881. And that works out to be 4.917, which ultimately rounds to 5 again anyway. All right, so we got a similar result, which isn't surprising because the numbers are pretty close together in range. Okay. All right, now we can go ahead. We can use that data, we can use the width, and we can finally construct the frequency distribution. Right? So for our frequency distribution, remember the lowest observation that we had was 3, the highest was 27. So we should start at 3 for our lowest class. And remember that 5 was the width, so we're going to add 1 less than the width, which is 4. So we end up at 7. And then we're going to have 8 up until 12, and then 13 up until 17, and then 18 up until 22, and then 23 up until 27. And the good news is, I believe 27 is the magic number that we need. So it looks like that everything's going to fit in the class. We need our frequency. All right, so I am going to copy down so I don't have to keep looking back and forth or to memorize it. So I'm just going to copy and paste these values down here. Or maybe up here. Oh, So for our frequency, we have 5 values, it looks like, that are between 3 and 7. And then we have, it looks like, another 5 that are between 8 and 12. And then we have 3 that are between 13 and 17. We have a 20, and then we have a 27. All right. And then finally, we can go through and we can get our frequency and our cumulative frequency, just like we've done before. We want to make sure that it does add up to 15, and you can do a clear inspection to see that this does add up to 15. Our relative frequency is going to be 5 out of 15, 5 out of 15, 3 out of 15, and 1 out of 15, and another 1 out of 15. And then finally, our cumulative frequency is going to be 5 out of 15, 10 out of 15, since 5 and 5 is 10, 10 and 3 is 13 out of 15, 3 and 1 is 14 out of 15, and fortunately, 14 and 1 is 15 out of 15. All right, so we're going to hold on to this information because in the next video, what we're going to do is we're going to use this to be able to construct our graphs, and then finally, we're going to be able to make some sort of conclusion about the relationship between people that are playing violent video games, and then to determine if there's any effect whatsoever on our empathy for another human being.